morning, good afternoon, and good evening to everyone, depending on where you are. It's a great honor to attend this city conference virtually in 2021. Welcome to our session. Today, my colleague Savita and I will co-present this topic on Tekton's hassle-free journey with Tekton Operator. Something about me. My name is Vincent Hou. I originally come from China. I used to stay in Belgium for 4 years to my colleague. Now I'm working in United States. Is this a hint that I know everything? I tried, but unfortunately not. I spent the vast majority of my time working with open source projects since I joined IBM in 2010. I used to work in Cinder, the block storage service in OpenStack. And later, I work on the serverless platform called Openshift. And currently, I'm co-leading the operators work in both Knative and Tekton communities. That's about me. So, Savita, would you please chime in to introduce yourself?
Thank you, Vincent, for the brief introduction. Hello, everyone. Hope you all are doing good. Myself, Savita Ashture. I'm based out of India, Bangalore. Currently, I'm working as a senior software engineer at Red Hat. I have a working experience in different open source projects like Cloud Foundry, Knative. And right now, I'm an active contributor on the Tekton. Please feel free to reach out to me on the Slack, Twitter, LinkedIn. The details are given here. I think that's all about me. Thank you. I would like Vincent to take over from here.
Thank you, Savita. I will go on with our agenda for today. First, we will explain what a Kubernetes operator is and why we use it. Then, briefly introduce the Tekton projects. After that, we go deep into Tekton Operator by walking through its functionalities and configurations. What benefits we have to use it. How Tekton Operator supports multiple Kubernetes platforms. What is special on Openshift and how CR behave differently in different platforms. We will have a demo for the operator today. And last but not least, there is a time slot dedicated to questions. What is a Kubernetes operator? The Kubernetes operator, in a nutshell, is a construct packaging, deploying, and managing a Kubernetes native application. It is like an automated robot managing the operation work to replace the human operator. To constitute Kubernetes native application, it must be deployed on top of Kubernetes and managed by kube APIs and kubectl tooling. Why do we use the Kubernetes operator? Automation. It automates everything, including the installation management, upgrade, etc., for container-based services. Offload human operators' work and make life easier. Based on the specification, the operator manages the application in a control loop, which checks the cluster to ensure the ideal states are fulfilled with the correct infrastructure resources. If the current status is not equal to ideal states, the operator will correct it. It also allows the users to interact with the complex applications with a single object called CRD. Operator introduces new CRs to manage the application. How could Tekton relate to the operator? We will be there. What is Tekton about? Tekton is an open source framework for creating CI/CD systems in the cloud native way. It consists of many components like pipeline, a set of CRs to create CI/CD systems, trigger, which is able to instantiate pipelines based on events, dashboard, a web-based graphical interface, catalog, which is Tekton's building blocks, and CLIs. Since it has so many components, installation and management can be a burden. You have to go across the different repository to find the correct links and apply them. Go to each correct resource for configurations. Not user-friendly. Is there an easier way? Yes. The operator is the one ring to rule them all. Tekton Operator by far can manage 3 major components with custom resources. It is expanding to manage more components. Lifecycle management and configurations of the Tekton components are done by CRs. The names of the custom resources are very self-explanatory. Tekton pipeline manages pipeline. Tekton trigger manages trigger. Tekton dashboard manages dashboard. To install each component, simply apply the CR in the YAML file. Each cluster only allows one instance of the Tekton component, so we define the CR as cluster scoped. One cluster only allows one CR. With the spec in the CRs, you can configure the target namespace. On top of the basic CRs, Tekton Operator also defines the CR name, the Tekton config, to manage all of them. There are 3 modes available to be configured in Tekton config. Default mode means to install pipeline and trigger. Basic mode means to install pipeline only. Full mode means to install all of the 3 components. Tekton Operator can constantly check the status of each component in the control loop and correct it if the current status does not match the ideal status in the specification. So the deployment resources are more resilient since they can revive automatically. The CR status can indicate the health of Tekton component. Tekton Operator is platform agnostic. For the next part, I will turn over to my colleague Savita for detailed introduction.
Thank you, Vincent, for the wonderful explanation about the operator concept, Tekton Operator, and the Tekton modules. So now I will discuss one of the benefits of Tekton Operator, which is platform agnostic. So that means Tekton Operator by default have support for the multiple platforms. This support of multiple platforms can be achieved with the help of extension mechanism, which is a feature from the Knative package. So as of today, in Tekton Operator, we support generic Kubernetes and Openshift. And we also have a roadmap for the different platform to be supported, but that depends on the use case scenarios. Like if anyone wants Tekton Operator to be supported as a default, then we can add those platform also. But it is in roadmap. It can be in action if there are any use cases scenario. So next we will see how these multiple platforms are supported and what are their directory structures. So you can see we have a config and reconciler directory structure for different platforms. So in the today's call, we are not going to discuss in-depth technical details about this extension mechanism considering the time constraint. Now let's just take the one use cases of Openshift where it is helpful, how this extension mechanism is helpful. So you can see on Openshift, we have a different CR called Tekton add-on, which helps to install the catalog tasks as a cluster task and trigger binding, which makes the Openshift users a use case scenario easy way. It means like a customers or a users on Openshift, they don't need to install the task from the catalog repo. Instead, when they install the operator, by default, those things will be installed. So while writing the resources of pipeline or trigger, they can directly make use of those existing inbuilt catalog tasks. This is where I just wanted to give a feature which is specific to Openshift. Now let's quickly understand what are the different CRs available on different platforms. So on Kubernetes, we have Tekton pipeline, triggers, and dashboard. And on the Openshift, we have pipeline, triggers, and add-on. So you can see pipeline triggers are common in both the platform, but dashboard and add-ons are differ for these two platforms. So this is kind of difference can be achieved, and we are able to do it today in the Tekton operator with the help of extension mechanism. So today we are planning to show how we can do installation, how the Tekton operator could able to do deployment restoration. Then we will show us example of pipeline deployment with the help of trigger. Even after upgrade, the example works seamlessly. And finally, we will see the uninstallation part. Let's start with the installation. This is the GitHub repo. So the prerequisite like ingress, the way of installation of the ingress. So today I will be using a GKE to show the demo what the K8 is. So you can see a GKE cluster is running. Now let's install the Tekton operator with 0.22.0. Now I will be installing Tekton operator, and meanwhile let's watch the status of operator. So you can see kubectl get deploy. Yep, it's up and running. Now we just the Tekton operator controller pod is running, which watches on the different CRs, so that will help us to install the Tekton components. So now to install the Tekton components like pipeline, trigger, and dashboard, let's use the custom resources. Let's apply this custom resource called config. Now we have applied the config CR. Let's watch the status of different CRs of Tekton. You can see Tekton pipeline is true. And similarly, watch for the Tekton triggers and then Tekton dashboard. If it's in the installation state, so it won't show ready as true. Instead, it shows the ready as false, and you can see dashboard as true. So now all are up and running, and you may be thinking in which namespace these components will be installed. So usually Tekton components are installed under the Tekton pipeline namespace. So you can see a different parts of the triggers, pipeline, then dashboard. Now let's install the ingress so that we can access the dashboard. This is how ingress looks like for the dashboard in the Tekton pipeline namespace, and the service name is Tekton dashboard. Let's apply the ingress. I'm in Tekton demo code itself. So I have applied the ingress.yaml. And meanwhile, let's get the ingress object in the Tekton pipeline namespace. You can see this one. It's execute. You can see still address didn't shows. Meanwhile, let's watch on that. Once this dashboard is up and running, we can see like what are the installed version of the Tekton components. Okay, so now the dashboard ingress URL we got. So let's do quick access on that. So you can see here dashboard is the path where it is actually running. This is how the dashboard looks like. So I won't go to different parts of the dash resources. Instead, I'll just show like what are the installed version of Tekton components. The next step is like how we do the deployment restore in the Tekton operator. So now let's do a deploy on the Tekton pipeline namespace. Let's remove one of the deployment. I'll just remove here. So you can see we expect to see the deployment resource is gone and relaunch. So you can see here Tekton pipeline got deleted and then it started creating it here. This is how the you can see a deployment restoration works. We are ready with the Tekton components installed on the cluster. Now let's understand how we can deploy the sample pipeline. To proceed with that, let's install the example. As part of this demo, what I'm planning to do is, I'm planning to install a task run based on the GitHub event. So this way I can cover both pipeline concept as well as a trigger concept. This is my event listener YAML, where it installs the task run. What it does is like it just clones the Git repository URL for particular revision, and it do a ls-lrt on that particular current working directory. This is where the task run will be installed. But when this task run will be installed, that is somewhere given by the interceptor, where we are integrating with the GitHub. So what we are doing, we are watching on the event of the pull request whenever there is a PR open. So whenever these three events occurs for the pull request specifically, that we are creating a task run. This is a simple example. Let's see it in action. So to do that, let's install the example and watch the pods which will be created here under pod section. Now you can see it's in the creating state. Now it's up and running. Let me do a tail on the log. It's waiting for the event. Now what we will do, the next step is to configure the URL in the GitHub setting, right? So to do that, I should have a publicly accessible URL. I have created a ingress, which I kept in the example folder itself, and my ingress look like this. So this is how my ingress look like, and it is watching on the service called EL GitHub Listener Interceptor. As ingress will help us to do a publicly accessible thing. So let me get the ingress IP and do a curl request. CI is the path where my ingress looks like. Now you can see a error occurs like invalid body format, and you can see logs in the event listener pod also. So this shows that, okay, the connection is working fine. Now let's do a settings as mentioned in the GitHub repo. So now let's go to Savita Ashture sample Go app, right? So let me quickly go over there, sample Go app, and in the settings, so here where we configure our webhooks. So before adding anything, I'm just straight away deleting the existing settings. Now nothing is there. Let's add a webhook here. Let me copy the URL from here and just remove it and add it. Then to application JSON content, and this secret is required for the authentication purpose. So this is the secret. I'll copy and paste it. As seen in the event listener YAML, I'm actually watching on the pull request event. So let me select the event instead of push. Let me just select the pull request part so that I can get the events properly. So let's add the webhook now. Okay, webhook is added. You can see some logs which indicates, okay, something is added, something happened on the webhook URL. Now what we will do, as per this, I'll go to the pull request. So for the time constraint, what I'm doing, I'm just closing the existing pull request and reopening the pull request. So you can see event messages displayed. We can see a task run getting created. So you can see 5 seconds ago. So it is succeeded. Now to see what is the task run actually doing, let's do a log-f, and you can see a ls-al, which is what I showed in the task spec. So this is where the task spec look like. This is where how we can do a installation and execution of the examples based on the trigger events. Next, what we are focusing is the upgrade part. So what we are upgrading the operator from 22.0 to 23.0. In 22.0, we will see installed component versions at 12.1, 22.0, and 15.0. And one thing to notice here, the whatever operator version will be there, that will be the pipeline version. So it will be easy for us to make sure, okay, whether it's upgraded successfully or not. Let's see it in the action. Now I will just copy the YAML. Now I have applied it. So meanwhile, let's wait for a minute so that it start upgrading the. I think I have did Control C. Let me do again. Kubectl get pods -n Tekton pipelines. So you may be seeing some pods are in terminating state, some pods are in creating state. So this is where it start upgrading the components. You can see the components version got upgraded like 13.0, 23.0, 16.1. So it indicates our upgrade is success. Upgrade of Tekton works. Once upgrade is done, you can see a event listener pod is also got terminated. So if I come and see here, do a kubectl get pods, you can see a pod is recreated in just a fraction of second of 55. So now let's do a kubectl logs -f. The next action is verify the example after upgrade. What I'll do, I don't do any changes. I'll resend an event. To resend event, I will again reopen the pull request. You can see a event occurs. So it indicates that after upgrade, our example works perfectly. Let me check a task run. You can see a new task run getting created. This is how we see the action of upgrade and the example verification after the upgrade. Last but not the least, we will see a uninstallation part. Let's first delete the existing running example to make sure everything works perfectly. So now let's clear this out. Let's delete the CR which got installed. So we should delete the CR first so that all the Tekton components will get deleted. So that we can observe here like we can refresh the dash portal. After a few seconds, we should see 503 error. Let's wait for a second. So it is in the deleting state. So meanwhile, if we want, we can see Tekton version to see like, okay, what all things got deleted, you can see. Okay, no versions are displayed, so it means the deletion is successful of the component. Now again, I will refresh it. You can see 503 service unavailable. Let's remove the operator deployment. So this is where we could able to uninstall everything successfully which are installed in our cluster. That's it from the demo side. Now I'll hand over to Vincent.
Thanks, Savita, for the demo. As you see, Tekton Operator has created a smooth way to install, manage, and upgrade the Tekton components. How do you like it? Give a thumbs up. We are working in an open community. If you are interested in Kubernetes native CI/CD, welcome to join Tekton. If you are interested in operation work, make life easier, welcome to join Tekton Operator. We are available on Slack. We run the regular meetings every week. We have listed several other useful links here for your reference. Thank you so much for having us. Don't forget, Tekton Operator is the wiring to rule them all because it can manage all the components in Tekton. This is Savita and Vincent to present you the Tekton's hassle-free journey with Tekton Operator. Now it's time for questions. Hello, everyone. Welcome.
Hello, everyone.
So, wiring to rule them all, huh? You like it or not?
Any questions?
We had a poll over here regarding how you install, configure, and manage your app service software operations. It could be something that you're familiar with. Yeah, as you see, the third operation is about Kubernetes Operator, what we have been talking about for today. We'll in a few minutes.
Yeah.
You know, when we come to not just Tekton Operator, Kubernetes may ask the question that what's the difference among help, Ansibles, and Kubernetes Operator. There should be some discussion even in Tekton. Some other communities, for example, I work with the community as well. They have been talking a lot about the differences of these different installing toolkits. I usually said, when we compare them, this is not a beauty contest. I say which person wants. It's how it fits your project's need. For example, when we talk about Kubernetes Operator, sure, number one thing, it is a Kubernetes application. So what's the advantage of Kubernetes application? You leverage the Kubernetes capabilities. You can create your own CI. You leverage the reconcile loop to compare between the desire and the actual states and move them from the actual state to the desired state. That's how Kubernetes application works. And number two, and CR's customer resource is not, I won't say unique, and that's the only source of truth for you to configure your applications. And usually before you install something, maybe you need to set your own parameters, but for Kubernetes, everything is done by CRs. As I think I see Savita has done the demo before we do the installation. We run the upgrades by the CRs. We remove them by the CRs. And the CR of the cycle matches the life cycle the operates. That's what I want to emphasize. And if you run into some errors, the status of the CR can indicate that you know what was going on and what was going wrong, and you can check the logs. Then either for the user or the developer, you can either move on your work or even to fall back. As you can see, our upgrades have the fallback option as well. So anything else you want to share?
Sure. Even we can say, like, if we just, even Helm also help us to do the deployment on top of Kubernetes, like managing the templates. But what I observe the benefits using Kubernetes Operator is to managing the day to operations. So if we make use of Kubernetes Operator, we could able to manage day-to operations like management, upgradation, rollback, those things easily through inbuilt features of like management kind of functionalities. But with the help of Helm, we could able to do the deployment, and even to manage Helm also we can make use of operators. So yeah, I agree with you. Like it all depends on our project use cases and the way we want to deploy our project and handle it. So based on the scenario, we can make use of Helm, Kubernetes Operator, Ansible, or if there are any other solution.
We should talk about, let's say, I would say buzzwords of cloud native and Kubernetes native. Well, with the help of Kubernetes Operator, it will surely make your app, let's say, Kubernetes native. That's what I want to say as well. Every tools, including even the administrators command lines, you can apply on top of your Kubernetes Operator. I think that's also the benefits you use Kubernetes Operator to manage your applications.
Yeah.
And within the ecosystem, I think we'll have public either while releasing the traditional way by publish your YAML somewhere, and you can also leverage, I think, the Operator Hub by wrapping with I think CSV artifacts. So that's exactly. So that's the Operator Hub can copy your repo to host all your operators and running managed by the OLM tools. That's what I can see. Yeah.
Yeah, yeah, that's where day 2 operations comes into play using OLM.
Okay. Cool. Well, guys, if you like the operator work, welcome to join Tekton Operator. And if you like CI/CD, welcome to join Tekton. We are open source community. So, also on top of the hour. So, enjoy the conference.
Yeah. See you.
Yeah.
Thank you, guys.